This webcast continues the discussion of the lab for energy transfer from gravitational potential energy to kinetic energy. And so we're at the point of writing some conclusions. And so I've given you in blue italicized font an idea of what the outline of the conclusion should be. You should definitely delete all of this blue italicized information in your final report. So the first step is just to, restate the objective. I'm just going to copy the objective from the front of the lab and, and maybe just make this a nicer sentence. So the purpose of this lab was to explore how energy within an isolated system redistributes between different energy storage modes when a cart moves down an inclined ramp. Specifically, we determined the relationship between the gravitational potential energy of the cart elevated on an inclined ramp and the kinetic energy of the cart near the bottom of the ramp. Okay, let's make sure that we double space. That's very important in conclusions. Okay, so I've done that, and I'm just going to indent here. Okay, so that's my first paragraph. Good enough. Then I'm going to go to the next paragraph. This is the point where you want to present your basic data. The relationship between your variables, we had to linearize it, so we need to describe how we did that, and then we need to give the physics equation. Okay, so let's say as shown in figure 2, the graph of the gravitational potential energy at the top of the ramp versus the velocity at the bottom of the ramp was curved and resembled a parabola. Therefore, the EG, and if we've already spelled it out once, I think it would be okay to use an abbreviation or a symbol here for gravitational potential energy. Therefore, the EG is proportional to the square of the velocity. Near the bottom of the ramp. The resulting, so you have to explain how you linearized it, and so I'm just going to say the resulting graph of gravitational potential energy versus the square of the velocity was linear, as shown in figure 3. The physics equation for this linear graph was as follows. You could go up and copy that physics equation, although I think I wrote it, so I'm going to put it in. It would be nice to put it in equation editor here, but I've got gravitational potential energy. I want to put my slope in parentheses. I don't remember the number. I'm just going to say 1.59. It was joules divided by meter squared per second squared. I'm going to close my parentheses, and then that was times velocity squared, right? Okay. We can't really explain the slope since we had to transform the data by squaring velocity, so I'm not really going to try to do that. but at least I've told how I linearized it, and I've given a good physics equation. Okay, that's my second paragraph. And then the third part is we want to talk about what that slope means. And so we could say the slope of figure 3 is similar to half the mass of the cart. That's evidence that the slope is very similar to that half of the mass. And then we also have evidence that the units of the slope simplify to be the units units of kilogram, the units of mass. Therefore, we conclude that the slope of the graph of the gravitational potential energy versus the square of velocity has a physical meaning, which is half the cart's mass. A more general equation using this meaning of the slope is as follows. And this is where we would put, the other equation that we wrote, which is that the kinetic energy is half of the mass times the velocity squared. Okay. So those would be kind of the conclusions. Once I've written some conclusions, I would definitely delete that blue italicized font. We don't really need that. And then I would go back and, straighten up some of my spacing so that everything fits and titles and everything are on the same page. Okay, that's our conclusion.